about the vector between 2 points. We've been talking about vectors for a few days now, talking about how they have both direction and magnitude. And we said that we can represent them by an arrow. You can have that direction pointed by that arrow, and that length is my magnitude. Or I can talk about it in component form. I can use that how many directions, left and right, east and west, and then up and down. Or I can use my unit vector form and say how many i's do I move right and how many j's do I move up. Today we're going to be talking about the vector between 2 points in a plane, between 2 specific points. So if I'm given any point A in the plane, if I have any points, let's say A1, A2, then it has that position vector from O to A. I say position vector. When I say position vector, I mean from that point O to A, from that origin to A. And so if I have B, let's say call it B1, B2, it has position vector, again from the origin is B1, B2. So if we look at this diagram, if I want to find AB, vector A to B, well I know that can be the sum of vector A, O, as in the origin, plus the vector OB. And I say, well, what AO and OB? Well, the thing is that if I have, what I'm summing here, that's a little bit confusing, but let's call it, what if I call it, I have these defined in terms of OA and OB, but I have AO and OB. How are AO and OA related? Well, if it's OA and AO, that's the same vector in the opposite direction. So AO is simply negative vector OA. So I have negative vector OA plus vector OB. And we know that vector operations are commutative. I really can switch the order here. I can say that's also vector OB plus negative vector OA. Or even more simply, say vector OB minus vector OA. Once I get those two set, I can actually substitute my components in, say B1, B2 minus A1, A2. And since I know the vector subtraction, I can't subtract the components. I end up with the vector, with my x component is B1 minus A1, and my y component is B2 minus A2. So notice that's also called the position vector of B relative to A. If I just say the position vector of B, that means from the origin to B. But if I say the position vector of B relative to A, that means where is B with respect to A? So I'm starting at point A, and my vector is going toward point B. That's also that position vector. With that in mind, we can talk about transformations. A vector can be described by this terms of transformations. If I'm translating point A to point B, that is that translation vector is from A to B. That's what we talked about when we talked about translations back in chapter 5. The horizontal distance that I'm translating is just that distance, that difference between my A1 and my B1, that positive distance there. My vertical distance can be found by that difference between my B2 and my A2. I can always talk about that distance as that difference in the coordinates. In general, if I have any 2 points A and B with position vectors vector A and vector B respectively, position vectors from the origin, I can say that vector AB is negative vector A plus vector B, which is the same thing as saying it's vector B minus vector A. Using that vector subtraction in component form, I can have the following. And if I have vector BA, I'm talking about the opposite direction as vector AB, so it can be negative vector B plus vector A. And I can say that addition is just subtraction. So vector A minus vector B, and then I can use my component rule for subtraction to find that one. So taking a look at my example, if I'm given 3 points, these 3 points specifically P, Q, and R, and it says find the position vector of Q, if I just say find the position vector of Q, I automatically know that it's from the origin. But in this case, it's saying the position vector of Q from O, the origin. It's explicitly giving it to me. Well, from Q, of Q from O means I'm starting at the origin and going towards Q. So I'm saying it's my Q coordinate, my 2, -4 coordinate, minus my 0, 0 origin. So when I subtract this, I'm left with that 2, -4. That's a position vector from the origin. If I say find the position vector of P relative to Q, again, I'm starting at Q and ending at P. I'm terminating at P. That's what I'm wanting the vector of with respect to Q. So vector QP, again, when I'm finding that distance, I'm finding that difference in my x-coordinates, difference in my y-coordinates, I want to start at that point that I'm ending with and say subtract that to find the difference. So I'm starting at vector P, 3, 5, and subtracting vector Q, 2, negative 4. So 3 minus 2 is 1, and 5 minus negative 4 is 5 plus 4 is 9. If I take a look at my next example, I say find the position vector of R relative to P. Again, of R relative to P means starting at P, ending at R. So when I'm finding that distance there, I'm going to say my R coordinate, my negative 1, 4, minus my P coordinate, my 3, 5. So I end up with negative 1 minus 3 and 4 minus 5. I end up with vector PR is equivalent to negative 4, negative 1. And this is the time that I would ask you to go to the board and check on this problem with your partners. So if you go ahead and flip to your textbook if you would like to have that extra practice on your own, and number 1C would be a good one to check on your own. If you struggle with this, please go ahead and post on the discussion board. I'm going to go on to the next example. If you have done the other one, go ahead and pause this and come back to the video, please. So example 4 says AB is the diameter of the circle with center negative 1, 2, and if B is 3, 1, find me BC, vector BC. And you're like, what? Vector BC? Well, in that case, I can say it's my C coordinate negative 1 minus my B coordinate 3, and my C coordinate 2 minus my B coordinate 1. And I can say that my BC, vector BC, from B to C is negative 4 over to the left and 1 unit up. Pretty straightforward in this case. But if I'm asked to say that same direction, saying that AB is my diameter and it still has the same points, but find the coordinates of A, and you're like, but Miss Mickle, A is not labeled. Right? How am I going to find this? Well, looking at what I've already found, vector CA is the same thing as vector BC. So if I could somehow talk about vector CA, I already know what vector BC is. And I know that if I have two equal vectors, that means their components are equal. So let's take a look at seeing if I can even find vector CA. Well, vector CA, if I give A the coordinates x, y, for example, I can say that vector CA is going to be my x coordinate minus my negative 1. And then it's going to be my y coordinate minus my 2. So I can say that vector CA is x plus 1 and y minus 2. But we've already discussed that vector CA is equivalent to vector BC. So if I set those vectors equal, I can say my components are equal. So I can say that x plus 1 does equal negative 4, or x equals negative 5. And I can say that y minus 2 equals 1, which means that y equals 3. I can solve. Now I know that point A is negative 5, 3. And after that example, I would then ask you to go to the board and work on number 4. I would recommend that as extra guided practice. If you have struggled with that one, please go ahead and post on the discussion board. If you understand that and you think you're totally solid, I would wish you the best of luck on working on your homework due tomorrow. Enjoy your E-Day.